Lesson number 94 is about uniform motion problems of the form d1 plus d2 equals n. And here, the d means the distance of our first object plus the distance of our second object will equal our final number or our final distance. So, our first problem. Let's begin. A southbound bus left Fort Walkton Beach at 9 a.m. Walkton should be capitalized, so let's do so. Fort Walkton Beach. 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate and were 352 kilometers apart at 2 p.m., find the rate of the buses. So if we draw a picture of this, here's our starting point. This may be the bus station. We've got a southbound bus that's leaving Fort Walkton Beach at 9 a.m. So southbound. We'll draw a picture going south. Then, 2 hours later, a northbound bus left the same station. So it left the same station going northbound. So, we're going north now for our second bus, and it says if the buses traveled at the same rate, that's important here, the same rate, and we're 352 kilometers apart at 2 p.m., find the rate of the buses. So that's what we have to find. They're both the same, and we have to find out what it's equal to. Now what we know in this problem is that our first distance, the distance that our southbound bus travels, plus the distance that our northbound bus travels, puts them at 352 kilometers apart at 2 p.m. So this distance at 2 p.m. is 352 kilometers. So what that tells us is that the distance of our first bus, or we're going to call it the distance of the southbound bus, plus the distance of the northbound bus, d sub n, will equal 352. Now remember, distance equals rate times time. So if we write that out, d equals RT, we can now go ahead and substitute R, the rate, times t, the time, in for distance. So the rate of the southbound bus times the time of the southbound bus plus the rate of the northbound bus times the time of the northbound bus is going to equal 352. Now there's some more information given here. It says the first bus left at 9 a.m. Then it gets there at 2 p.m. Well, from 9 a.m. to 2 p.m., that's a total of 5 hours. So the time of our southbound bus is going to equal 5 hours. Then 2 hours later, the northbound bus leaves. This whole thing is being compared at 2 p.m. So the time of the northbound bus is going to be 2 hours less, which is 3 hours. And then the other key fact that we know is they both have the same rate. So the rate of the southbound bus is equal to the rate of the northbound bus. Now we can substitute all of this in for our equation and then solve. Let's do that. We know the rate of the southbound bus equals the rate of the northbound bus. So we substitute in R sub n. The time of the southbound bus equals 5 hours. Plus the rate of the northbound bus. Well, we know that the rate of the southbound bus equals the rate of the northbound bus, so we keep this the same, the rate of the northbound bus. We know to keep it the same because we need to have the same variable twice, times the time of the northbound bus, which is 3 hours, equals 352. So, if we add up our rates of the northbound bus, we have 5 and 3. That's going to give us a total of 8 times R sub n equals 352. Then we have to divide both sides by 8. The 8's cancel, leaving us with just our rate of our northbound bus. And we're going to divide it by 8 on the other side of our equation. Now we're running a little short on space. Please pause the video now if you need to get this information about our times and rates in your notes. Okay, let's solve this last piece. We have 352 divided by 8. Well, 8 is going to go into 35 4 times. 8 times 4 is 32. That gives us 3 left over. We bring down our 2. Perfect. 8 goes into 32 4 times. That's 32 with nothing left over. We've got our final answer. The rate of the northbound bus equals 44. And in this problem, it's kilometers per hour, since we're talking about the hours. So 44 kilometers per hour. And we know the rate of the northbound bus and the rate of the southbound buses is the same, So our rate here, we can just describe our rate as one thing for both. Our rate is equal to 44 kilometers per hour for both buses. Let's look at one more example today. Two ships were 400 miles apart at midnight and were headed directly towards each other. So if we draw this out, if we have two different ships going directly towards each other, and they were 400 miles apart at midnight. They collided at 8 a.m. Find the speed of both ships if one was 20 miles per hour faster than the other. So in this one, if we look at it, two ships, they're 400 miles apart. So what we know is the distance of the first ship, and we'll call this d sub f for the first ship, plus distance of the second ship, d sub s, will equal 400. Now instead of saying the distance, let's use the rate times the time. Notice that the variables stay the same. The subscripts f and f go with the rate and the time for the distance. The s for the second go with the rate and the time for the second. And they're all equal to 400 miles. Now it says they started at midnight and then they collided at 8 a.m. Well, from midnight to 8 a.m. is 8 hours. So our times, the time of the first ship equals 8 hours, and the time of the second ship is also equal to 8 hours. Now it says, find the speed of both ships if one was 20 miles per hour faster than the other. So it looks like, this is my second ship, it looks like it's gone a slight bit further than our first ship. So if we were to look at that, we can say the time of the second ship is equal to, pardon me, not the time, the rate. The rate of our second ship is going to be equal to the rate of our first ship plus 20. So that means the second ship is going 20 miles per hour faster than the first ship. Let's go ahead and substitute in now. T sub f equals 8. T sub s equals 8. Whole thing equals 400. And we know r sub s equals r sub f plus 20. So let's make a little bit more room here. R sub s is equal to r sub f plus 20, r sub f plus 20, and then we've got r sub f. Now this problem looks slightly different than our last one. Here we have the distributive property. We need to multiply 8 times r sub f and 8 times 20 before we can simplify to solve. Let's do that. We're going to get 8 times r sub f plus 8 times r sub f is 8 times r sub f plus, because that's what the problem tells us to do, and 8 times 20 is 160. This all equals 400. Now, in order to solve, let's put together our r sub f's. We're going to have 16 r sub f's because 8 plus 8 equals 16. And then if we subtract 160 from both sides, 400 minus 160, that must equal 240. 16 r sub f equals 240. Now our final step, let's erase a little bit again. Please pause if you need more time. We have 240 divided by 16. 16 is going to go into 24 one time. That's 16 with 8 left over, and we bring down our 0. 16 is going to go into 80. How many times? 16 is going to go into 80. Well, let's try 16 times, we'll try 16 times 5. See what we get. Well, 6 times 5 is 30. Carry the 3. 5 times 1 is 5, plus 3 more is 8. Perfect. So it goes in 5 times. We've got no remainder. What that means is r sub f, the rate of our first ship, is going to equal 15. And in this problem, it is miles, and it must be miles per hour. And remember that fraction bar just means per. So this is 15 miles per hour for the rate of the first ship. Now, careful, don't move on too quickly. It says, find the speed of both ships. So what we need now is the rate of the second ship. We know that the rate of the first ship, and we had our equation written over here. Let's rewrite it. You should have it in your notes. Take a look at it. Let's erase our division. We can refer back to here. We know that rate of the second ship, R sub s, is equal to the rate of the first ship plus 20. We can see that because we've shown our work. Please show your work so you could look back if that were ever to happen to you. So the rate of the second ship equals the rate of the first ship plus 20. So we're going to get 15 plus 20. That equals 35. So we've got our second answer. The rate of the second ship must equal 35 miles per hour. Let's box that one, make it clear that that's our second answer. And we're all done with this problem. Key thing here is to remember distance equals rate times time. Then we can substitute in to help us solve our equation. Lesson practice will be on page 393. Make sure you've got your notes complete, and I'll see you during our next class.